Everyone, welcome back to my channel, and today we will solve the daily LeetCode problem. And for our today problem, we need to do something like we need to find some kind of the return array to satisfy the query. So this problem is a little bit difficult to understand from my perspective because firstly we need to construct the power array, which is something like that is the composed of the minimum number of power of 2 that sum to the n, with the n is a given number. For example, like in this case, or in the first example, we are given the number 15th, right? And what is the 15 in here? And so in here, like, we can decompose the 15 into the array of the power, and each element in the powers array in here we have, that is the 1, 2, 4 and 8, that is the power of the 2. So we can prove that like there's no smaller arrays can represent for the number n, which is the 15 in here. So what does this mean? And I think that the trick is in this case. So in here, like, we can see that how can we find the way to decompose the n into the power, right? Because like the powers will differ from example to example. For instance, like in the example number 2, in here we can see that like the number of power is the 2, right? So in here, because like for the given n is 2, and then we need to find the minimum number of power 2's that sum to the n. So in here, like, instead of doing like 0, 1 or something like that, and then we just like use the n, that is the 2 power 1, and then we can have only one element in the powers. However, like in this case, we can represent the 15 using 1, 2, 4 and 8, right? So how can it how I think that like, because like the powers that is different from the case to case, so how can we find the array powers? Okay, so we need to based on an intuition and observation in here, is that like the bit representation for the n. For example, with the n equal to 15, and then we can represent is equal to 8 plus 4 plus 2 plus 1, right? And this one is what? This one is 2 power 3 plus 2 power 2 plus 2 power 1 and plus 2 power 0. So this means that in the binary representation we will have the 1, 0, 1, 1, 1 and 1, right? This is the binary representation, with this one is the most significant bit, right? Okay, so in here, like, what if we have the 8, that would be like 1, 0, 0 and 0, right? So what does this mean? So in here, like, you can see that in here, based on the bit representation, we can see that like okay, so in here, like, I have the 15, so it means that I will put all of the number which has the bit position in that index equal to 1, right? So for example, like in here, because like all of the in here, that is the 0th, right? That is the first one and the second one, and until the third one I have the bit number 1. So that is the reason why it's better for me to construct the power array, that is the 8. However, in here, all of the bits in here, that is like when I encounter the 0 in here, right? And this is the 1, this is the 2, and this is the 3. And this one, like when I encounter any kind of the bit 1, then I will construct add that element into the array. For example, like in here, that is the 1, right? We add 1, that is the 2 power 0, and then next one we will add like 2, right? 2 power 1, and so on and so forth. We can have the result as the 2 power 4, 3, 2, 2 and 2 power 3, right? This is the way we can construct the elements. So how many elements in this array we can have, right? Because like we only can have 32 bits to represent a number in our system, and then that is the reason why. And this one is the it is for both the negative and positive numbers. So that is the reason why we only have 31 bits and then so that is the reason why like the largest positive number is just like 10 power 31 minus 1. And so here like we have at most like 2 power 30, right? And then at max like we can have only 30 elements or like 31 elements, right? Because it starts from 0. Okay, so when we can find the powers, and so it is ready for us to do the queries in here, because the length of the query in here, that is like 10 power 5. And then for each time we will iterate through each element in here. And then so because this one is only 30, and then it is around the 30. And then okay, so at max, and then each query will have 30 again. Yeah, okay, this one is much smaller than 10 power 9. And then so it means that like we can solve the problem anyway. Okay, so let's do it together. So firstly, we need to get the bit manipulation of the n. So let's say that is the bit, and I will use the here like we will have the bit representation for the end. And unfortunately, this function bin will give us like the string, and then the first two number will be the representation like 0b or something to represent for the binary. So that is the reason why we will interest in the from second index of this one. And then because like this one will be sorted from like the most significant bit first, so that is the reason why I just want to transform it into least significant bit first, to easier for us to enumerate through the array or iterate through our array, right? So here like let's print the bits first. Oh, okay, so you can see here we can have the bit representation for this. Let's try it as 8. Okay, so you can see that here like that is the bit representation, and then we have the least significant bit first. Okay, so for now we have the bits, and then like we need to do what? Like for now we need to get the power, right? And then we will iterate through the bit. And if the bits of I equal to, in here that is the string, so that is the reason why we need to get the character. Yeah, so and then we will append, so we get the power, we get this one to power 8. Okay, so print power. This one is for the 1. If bit I is equal to 1. Okay, because in here like I put that is the 8. Okay, so let's try it again. Yeah, 198, because so for now we will simulate for the first example, right? And for now, because we have the end query, and then we just need to get about the queries. And so in here for each query, let's say that because we do something with the multiplication, so the initial value for the return value would be the 1, and then we just need to get the ith in range of query 0, right? And until the query 1 plus 1, right? Because it is inclusive, both the left and the right will be inclusive. So in here like for the red vault, and then we just need to get multiplied with what? With the power I, right? And because like we need to get the return value, which is modulo to this number, so we need to return we get the red value. We need to get the return array first. Okay, so we return array dot append, and then red vault modulus the 10 power 9 plus 7. So in here like you have two choices. First one is like you just like assign this one into just do the number. However, like in here, I want to do inline operation, and then this one will be like faster in terms of computation, because like the accessing time for the memory, which is like uh, it is often like slower than the things like we do the computation directly. Yeah, so after this, and then I just get the red array. Okay. Okay, so this is the our solutions for us, and I don't think that that is too difficult for you. But the challenge is that like how can we find the power efficiently? Yeah, it requires us to have some kind of the intuition in this problem, and because like this one is the weekly contest, and in the weekly contest or like the bi-weekly contest, I think that like we always to need to do something like the observation, and then so we can solve the problem efficiently, because like that is limited time contest, so that is the reason why they don't want to do something like too difficult, but we need a intuition on observations. Okay, so that is, I think that also thing for our today LeetCode problem. Thank you so much for watching my video, and if you like and if you want to give me more motivations for me to do the future videos, please give me a comment or like a subscribe. Thank you again, thank you so much for watching my video, and see you next time.